Hello, hello. So we are going to talk about exponents today. Today's going to be the first lesson in exponents that we do. We're going to spend a lot of time on exponents. Exponents are going to be seen in every single math course you take from here on out, whether it's geometry or algebra 2 or calculus or trig. You're going to see exponents the rest of your life. So, we're going to start off with some important vocabulary. If we look at this piece, 2 to the third, the little 3 is called the exponent. It's going to be that tiny number. What the exponent does is it says how many times we're going to multiply the base by itself. So in this example, I have 2 to the third, meaning I'm going to have 2 times 2 times 2. I multiply 2, which is my base, by itself 3 times because 3 is my exponent. So we have exponents, which say how many times we multiply the base by itself. And then we have my base, which is just the number or the variable that I multiply by. Now your base is going to be letters and numbers. You'll see both. So we're going to go through some examples to kind of see what this looks like, maybe without just numbers. So the first thing is I have a property. It's called product of powers property, and it's multiplying powers with the same base. What this means is I have the same base is 2, and each base has a different exponent. One has 4 and one has 3. So my rule is when I'm multiplying powers with the same base, I add the exponents. So this is the general form of the rule. X to the a times x to the b equals x to the a plus b. So if I were to do this with this example, 2 to the fourth times 2 to the third would be 2 to the 4 plus 3, or 2 to the seventh. Well, you can use your calculator to say, well, if you have 2 raised to the seventh, you get 128. So sometimes you could get a numerical answer, but in this one, it's just going to be x to the a plus b. I can't simplify that anymore. So here are some examples. In both of these examples, you can't just use your calculator to get the right answer. Y to the fourth times y to the fifth, well, y is the same base, so your answer is going to be y raised to some power. I'm multiplying the same base, so I add my exponents, and I get y to the ninth. That's all you're doing, just adding those exponents, and sometimes if your answer, actually all the time, if your answer is some variable like y or x, your answer is going to be y or x. Let's take a look at number 2. It says, can we add negative exponents? So we have x to the 8th times x to the negative 2. Well, that's going to be x to the 8 plus negative 2. Well, what's 8 plus negative 2? Isn't that just 6? So x to the 8th times x to the minus 2 gives me x to the 6th, and I'm done. So what if there's no written exponent? This is my question over here. I have y to the minus 3 times y to the 7th times y. Well, if there's no exponent there, we're going to write that that's an assumed 1. That's not a 0. Something raised to the 0 is just 1, so it's not 0, or else it would say 0. Just having a y there means y to the 1. It's just you don't have to write that 1. So if you have y times y times y, you're multiplying the same base. You're going to add the exponents together. So you get y to the negative 3 plus 7 plus 1. The key with these is don't forget about that 1. A lot of people just say, oops, and forget to write it. Well, that's not the same thing. That's the wrong answer. So y to the negative 3 plus 7 plus 1 equals y to the positive 5. What this is saying is I can put any number in for y. I could make y equal to negative 2. Y could be 100. And my final answer would be that number raised to the 5th power, or that number times itself 5 times. Those are the same thing. So let's take a look down here. It says, what are my like bases? Well, if I look at my bases, I have a base of x, and then I have a base of y. So I have x to the 6th, x to the 7th. If I combine my x's, I get x to the 6th plus 7. When I look at my y's, I have y to the 1, y to the 3rd, and y to the 2nd, so my y's would be raised to the 1 plus 3 plus 2. Since all of these signs are multiplying, that means I can combine all my bases if they're alike. So even though this piece right here doesn't have an x written, this is all multiplication, so I'm actually using my commutative property of multiplication. I know that's hard to think about and it's hard to believe, but we are. So x to the 6 plus 7 is x to the 13. Y to the 1 plus 3 plus 2 is y to the 6th. So your final answer is x to the 13, y to the 6th. It's just like combining like terms. Look at the bases that are alike and then add those exponents. So here's another one. I have negative 2 and 9 are my number bases. Then I have x and x, y and y. So if I multiply my numbers first, I have negative 2 times 9. Well, negative 2 times 9 gives me negative 18. Now let me look at my x piece. I have x squared and x to the 8th, so x to the 2 plus 8. And then I have y to the 0 plus y to the 3rd, so I get y to the 0 plus 3. I know this looks kind of crazy, but just treat it like terms, and you get negative 18 x to the 10 y to the 3rd. And that is your final answer. Number 6, are my bases alike? I have x to the 3rd times y to the 3rd. Are x and y alike? No, they're not like terms. So if they're not alike, you just leave it x to the 3rd times y to the 3rd. That's all you can do. There's nothing else you can do. You can't make that xy to the 9th or xy to the 6th, they stay separate. If they're not alike, they stay separate. Well, now I have negative x in parentheses to the 7th, negative x in parentheses to the -5, and negative x in parentheses to the 10. These are all the same base, so I write my base, I add my exponents, that's a -5, and I get negative x. 7 plus -5 gives me 2, plus 10 gives me 12. So my final answer is negative x in Last page, I want you guys to try this one on your own. So pause this and then check your answers in a minute. Ready? Pause. Now check your answers. We have 14x to the 7th for number 8, 22x to the 8th, y to the 5th for number 9, and then negative y in parentheses raised to the 14th. So this is my property of when I multiply like bases, I add my exponents. So go through these next couple and try them on your own. Good luck, and I'll see you next time.